Hi and welcome to term 6. We're on the home straight for this year. Today's topic is on scale factors, which I want to look at today, and your starter task is on the 4 pairs of shapes that you can see on the screen. So I'm going to attach these to you, and what I'm going to do is work out the areas, and then using the fact that there's a length scale factor between each of these pairs of shapes, I want you to then also work out what the area scale factor is as well, because it's not necessarily going to be the same. Okay, so as an example, let's take a look at the rectangles. So the area of the small one is, looking at area, 1, 2, 3, 4, 5 by 2 is 10. Okay, don't worry about units, just put the number for what the area is. Then that shape's been enlarged to make the big one, okay, and it's been enlarged with a length scale factor of 3. So all of the lengths are now 3 times as big. Okay, so it was 2 and 5, now it's 1, 2, 3, 4, 5, 6 by, and it should be 15. Okay, so if it's 6 by 15, then that makes the area 90. Okay, if you want to, if it might help you out to put the lengths on, so it was, I'll do it in a different colour. 2 by 5, times these by 3. No, I won't do that. Times it by 3, 2 times 3 is 6, 5 times 3 is 15, and the new area is 90. Okay, then from that, we've got 2 areas. I then want the area scale factor. Okay, so the areas are times by 3. What's the area times by? Well, to get from 10 to 90, you times by 9. So the area scale factor is 9. Okay, right, so I want you to do that with the other pairs of shapes. Okay, the scale factor goes from small to big. These two squares, so you've got small square to a big square, you've got small parallelogram to big parallelogram, and then small triangle to big triangle. The scale factor for this one is 3 halves there, or you can think of it as 1.5 if you want to. And I want you to figure out the area scale factors. Okay, I'll attach the answers, and then when you're done, I will pause the video, and then I'll come back and give you the answers, and then we can move on. Okay, so let's look at the answers to some of these then. We'll do the squares next, because that's the next easier shape, I think. So for the small square, well, that's just 2 by 2. So the area of the small one is just 4. And the big square is 4 times as big for the lengths, so 2 is now 8. Make a better 8 than that, I think. And it's by 8 as well. So then the big square has an area of 64. Maybe we should have done this as a blue as well. Let's make that blue. Okay, so length scale factor is 4. 2's become 8s. But what has the areas done? Well, to get from 4 to 64, you multiply by 16. So that's the area scale factor there. Okay. Right, moving on to the parallelograms. We've got small parallelogram is 2 along the base. And it's 1, 2, 3, 4, 5, 6 high. So multiply those together. The area of the small one, 6 by 2 is 12. Okay, and then to get to the bigger shape, this has been enlarged scale factor 2 for the lengths. So the 2 has become a 4, and the 6 has become a 12. Okay, I'll just put up arrow and down arrow. You can check that by counting. Times them together, and the big area is 48. Okay, so let's put that down here to put these together. Oh, sorry, that's not the area. The area's gone from 12 to 48, so what's the scale factor? How many times bigger? 12 to 48 is times by 4. Okay, so we've got 3 pairs so far. I'm going to take a look at these and see if you can think of a link before I do the last one. Let's do the triangle finally. So the small triangle is 4 by 1, 2, 3, 4, 5. And the area of the small one then is 4 times 5 is 20. Divide it by 2, remember, for a triangle, that makes 10. For the big triangle, it's 1.5 times the size now. So 4 has become 6. And 5 has now become 7.5. Okay, so then the area, 6 times 7.5, divided by 2, and you get 22.5. Okay, so then small area, big area. What it might be helpful to do is you can maybe turn this into a decimal if that helps you out. If this is 1.5 for 3/2, then to get from 10 to 22.5, you want to be multiplying by 2.25. Okay, so let's take a look at these pairs of values. If I circle them in red, you need to think about what you notice about these pairs of numbers. You've got the length scale factor and the area scale factors. Okay, and hopefully, at least for these nice numbers here, these nice 3 over here, you've spotted that the area scale factor is the square of the length scale factor. Okay, so if you know what the lengths are multiplying by, then you square that number and that makes the area scale factor. Okay, same for this one. 4 squared makes 16. Can't draw squares today. And 2 squared makes 4. And you can check that 1.5 squared makes 2.25. Okay, so that's the relationship between the two different scale factors, okay, lengths and areas. So if I give you two shapes, which are enlargements of each other, okay, and I'll give you the term for that in a second, you've got to be able to work out missing lengths and missing areas. Okay, so before we do that, you need to write this sentence down to show what we mean when shapes are enlarged. So there's a special name for that, beginning with S. So enlarged shapes, so two shapes which are enlargements of each other like this, we call that similar. Okay, and that's the mathematical word. Okay, so it's worth you making a note of that so you know what that means. So the two triangles are similar, the two parallelograms are similar, and so on. Okay, because they're enlargements. Right, so we're going to be using this fact then to work out some missing lengths on things. All right, and to help you do that, I've put together this template here that you can fill in with numbers that helps you work things out. Okay, I think it's going to be quite useful to you. Okay, I'm going to put that on a PowerPoint. So I'm going to give you some examples then. Looking at the two posters for a film that you might have seen, we've got a small poster with this diagonal length on as 5 meters, and the big blown up poster with a diagonal length of 20 meters. Okay, and then we're told the small area, and we want to work out what the big area of the poster is. All right, but that's all the information that we need to do it. And to help you figure it out, you need to put the numbers into this template here. All right, so on the bottom row of this template, these are where all the lengths go. Small length here, large length here, and that's for the small shape. Oh, sorry, lengths. Small length for the small shape, large length for the big shape, and the length scale factor there. On the top, these are all areas. So small area for this shape, large area for this shape, and the area scale factor in the middle. And then remember, we've got this fact that links the scale factors together, which is you square to get from length to area. If I want to go backwards along that, you can square root to go back again. Okay, so depending on which way you go, up and down, you can use either of these two arrows. Right, so let's see what we've got and put them in the right place. The thing that we want to get is the large area. Okay, we're aiming for this one. Right, because that's the area of the large poster. But we've got small length of 5. Okay, doesn't have to be a length along the edge. It can be any length that you measure on that one, as long as it's the same length that you measure on this one. The large length is 20. Okay, and we've also got the small area as well. I'm going to put that in as 30. Okay, now I'm going to pay attention to the units. All right, when you write the answer down, you want to make sure that the units match what they were to begin with. Right, that's all I've got so far. Is there anything I can work out from this? Well, I've got both the lengths down here, so I can probably work out a length scale factor. 5 times something makes 20. I reckon that something is 4. Okay, if you can't work it out, you can do 20 divided by 5, and that makes 4. Now I've got this one. It's a bit like a Sudoku now. You can fill in bits as you go. I've got the 4. I can use this fact that gets me up to the top. 4 squared makes 16. Okay, so now I can fill in this one, and this tells me the scale factor between the areas. And if I know the small area, I can times it by 16, and that makes my large area, which is 480. Okay, so just to recap, using the template, fill in the numbers that you know, use the arrows to get upwards and downwards from the middle here, and then use what you've got then to work out anything that's missing. Okay, so that's done. That's the answer there, 480 meters squared. Let's do a couple more examples, and then there's some that I want you to have a go at. So here's another one. I've got maybe a small map of the UK, and then one that's been blown up to make it bigger. So what I want this time is the smaller area, but I've got these two lengths to work with as well. So let's put them in. I've got small length 1.2, large length is 6, and large area this time is 50. Okay. Right, same as before, I can work out this scale factor in the middle. If I work out what my 1.2 has been multiplied by to get to 6, that's going to be 5. Okay, then I can square my scale factor to get the area scale factor, and that's 25, 5 times 5. Okay, then finally, something times 25 makes 50. Well, that's nice and easy. That something is 2, and that's the thing that I wanted to work out, and it's in meters squared. So I'm going to keep it as meters squared. Okay, that's the second one. There's one more I want to do where you have to go down a level, and I'll show you what to do with that, but it's very much the same. So these two are water droplets. I've measured their areas, and I've measured one of their lengths, and I want to work out the small length. Okay, so let's fill them in as we see them. This 5 is the small area, that can go there. This 28 is the large length. And this 80 is the large area, that's going to go up there. Okay, so those are the three numbers that I know. I'm after the small length, that's down there, so I'll put my asterisk there. That's what I'm aiming for. I've got two numbers on the top, so I can hopefully work out the one in the middle. If you can't work out how many 5s go into 80, you can do 80 divided by 5 on your calculator, and that makes 16. Okay. Now, if I want to go down a row from area scale factor to length scale factor, it's along this arrow, so that's square rooting. Don't forget that it's not halving, you're working out what squares to make 16, and that's 4. So that's my length scale factor. So then something, the thing that I want, times by 4 makes 28. If you divide 28 divided by 4, that makes 7. And we're working in millimeters, so I'm going to keep it as millimeters. Okay, so if you want to draw this template, you can. Otherwise, I've attached it for you if you want to use it. Otherwise, however you want to set it out, that's fine. But that's the method that you need to be using to work out these missing things, okay? And the bit in the middle here is the important bit. All right, best of luck with today's work, okay? Hope you get on all right with it. Thanks, Year 9.